Hello, everyone. Today I'd like to walk through how to think about load balancing in system design. Load balancing is not just about distributing traffic. It's really about where you place intelligence in your system and how you balance performance, flexibility, and complexity. When I think about load balancing, I usually break it down into three dimensions. First, L4 versus L7 load balancing. Second, server-side versus client-side load balancing. And third, the trade-offs between performance, flexibility, and complexity. Let's go through them one by one. Let's start with L4 load balancing. L4 operates at the transport layer. It routes traffic based on IP and port. This makes it extremely fast. There's minimal parsing, low latency, and very high throughput. But it comes with limitations. It has no understanding of request content, so it cannot route based on URL, headers, or cookies. So the key idea is L4 is optimized for performance, not intelligence. Now, let's look at L7 load balancing. L7 operates at the application layer, typically HTTP or HTTPS. This allows it to route based on request semantics, things like paths, headers, or user sessions. For example, you can route DARM API and images differently, or enable A/B testing and canary releases. But this flexibility comes at a cost. It introduces higher latency and CPU overhead because every request needs to be parsed. So the key idea here is L7 provides flexibility and intelligence, but at a higher cost. So in summary, L4 is fast but simple. L7 is flexible but heavier. Server-side versus client-side load balancing. Next, let's talk about server-side load balancing. This is the classic model. Client to load balancer to service instances. All routing decisions are centralized. This makes the system easier to manage. Clients stay simple and control is centralized. But it introduces an extra network hop, which adds latency and can become a bottleneck. So the key idea is server-side load balancing simplifies architecture but adds overhead. Now let's look at client-side load balancing. Here, the client queries a service registry and directly calls a service instance. This removes the extra hop, which improves latency and scalability, but it increases complexity. The client now needs to handle service discovery, retries, and load balancing logic. So the key idea is client-side improves performance, but shifts complexity to the client. Trade-offs and real system design. So how do we choose? When you need ultra-low latency and high throughput, L4 is usually the right choice. When you need smart routing or user-level logic, L7 becomes essential. When you want to optimize service-to-service calls, client-side load balancing can reduce latency significantly. But, in reality, most production systems use a hybrid approach. Client to L7 gateway to L4 load balancer to service to client side. The key idea is different layers optimize for different goals. To summarize, L4 solves performance problems, and L7 solves routing and flexibility problems. Client-side load balancing solves scalability and latency problems. In real systems, we usually combine all three approaches. To conclude, load balancing is not just about distributing traffic, it's about where you place intelligence in your architecture. L7 centralizes intelligence, client-side distributes it, and L4 removes it for performance. The real challenge is choosing the right level of intelligence for each layer. Thank you.